Thanks everyone for taking the time out to attend GSC. This is actually the last day today, and we've got a packed agenda for DB2 today. And to kick it off, we've got Julian Stuhler from Triton with automating schema changes. Now, Julian's done 30 years in DB2, which is actually about the same as me. He's been worked on applications, been a DBA, looked at architecture, performance, tuning, just about everything really. So he's had a bit of a go at everything. And today he's going to look at automating schema changes. Before we start, just a few points. Please do support our two charities, which is the RNLI and Guide Dogs for the Blind. Still time to make contributions to those two charities, so please do that. If you've got any questions, please do ask in the chat and we'll get around to them. If you really want to make a point and ask a question, you can stick up your hand and I can unmute you. Otherwise, I think that's about it. I'll hand over to Julian and away we go.
Okay, thanks very much, Colin. Good morning, everyone. Thanks for starting relatively early in the day and joining us for this session. So as Colin said, I'm going to spend the next 45-50 minutes or so talking to you a bit about the practical experiences we've had in automating DB2 schema change. So I'm going to concentrate here less on the mechanics of actually doing the automation. I and many others have done quite a few presentations on that over the last year or two. So I thought we might take a slightly different angle for this presentation season and talk a bit about some of the things that go around the basic mechanics of the automation, some of the considerations and other challenges that you might face, and how I've worked with customers to go away and solve those challenges and put some practical solutions in place. I'll skip over the charity bit. Colin's already covered that. I'm going to skip fairly quickly over the introduction piece as well. I'm going to have a quick review of the basic mechanics. I'm not going to focus on that by any means, as I just said. I want to focus really on the third major section here, which is the real world challenges and solutions, and hopefully give you a bit of insight as to some of the ways in which we've overcome those challenges. I'll talk briefly at the end of the presentations about some of the benefits that we've seen, and then try to wrap everything up in the end. So I'm expecting to speak for around about 40 minutes or so this morning, so we've got plenty of time for questions. So please do, as Colin said, either put something in the chat or raise your hand virtually, and I'll do my best to answer those as we go through the presentation. And as I said, there'll be some time at the end there to answer questions as well. I won't dwell on this. Colin's already very kindly read out my bio. Most of you know who Triton are. We've been knocking around this industry for long enough now. I will just say a few bits in terms of a disclaimer, though. I'm not intending to present any of these techniques as being the best or the definitive ways of sorting these things out. I will be talking about specific tools and techniques. But those of you that have been involved at all in DevOps or get involved in the culture around DevOps, you'll know that one of the defining characteristics is flexibility and adaptability, and the culture is very much about working around issues and being creative in terms of coming up with challenges to problems. So although I'm going to present a specific set of tools, a specific set of techniques that we've used to solve these challenges, there will be many other ways of addressing those same issues. And as I said here, sometimes the best tool for the job is whatever you have available. Those of you that are into DIY, I'm sure some of you will have used implements other than a hammer for banging in a nail on occasion. If you happen to have a stapler or something else heavy around, I've certainly used that instead of a hammer, simply because that stapler happens to be to hand and the hammer's down in the garage. And it's much easier to use a tool that you have easily to hand rather than a specific tool if that tool is easily available to you. So just bear that in mind when it comes to some of these tools and techniques that we'll be discussing. Okay, so I want to spend 5 minutes or so kind of setting the scene and talking about some of the techniques and challenges around schema change and the mechanics of actually automating schema change itself. And as I said, this is a fairly well-worn trope now. I don't think this will be news to many or even any of you in terms of some of the reasons why people are doing this and some of the techniques that do it. DevOps isn't a new thing. It's been around for many, many years in one form or another. The early emphasis was very much in terms of improving cycle times, reducing time to market, making application development more efficient by automation and by putting a closer connection in place between the development and the operations side of the business, breaking down those traditional walls and getting developers much more involved in the operations side, closing the feedback loop and getting operations much more closely involved in the development side. So you get the nice little infinity symbol that most people identify with DevOps. Some fairly clear benefits for going down that path. But as I say on the slide here, traditionally the focus has been very much on deploying changes to application code. And while that's great, and it's obviously of great benefit to be able to quickly and efficiently and safely deliver application change on the route to live into production in a highly automated and orchestrated fashion, sometimes those application changes actually involve database changes as well. In fact, quite often they'll involve database changes as well. And I've seen quite a few situations where customers have invested in DevOps. They've got a fully or partially automated process for delivering code change into production, for regression testing and integration testing that change in a very efficient manner so that they can be very slick and efficient in terms of delivering that change. But in those situations where the change involves a associated amendment to the schema, the DB2 schema that goes alongside that application, very often that will still be a highly manual process. And by manual, I don't mean that we've got DBAs going and creating from scratch scripts to unload and alter and reload the database. Most mature DB2 sites have vendor tools to go away and actually manage that, but it's still being driven in a manual way very often by DBAs sitting in front of a green screen and driving the associated changes. So you get this kind of velocity mismatch where it's very quick and efficient and slick to be able to deliver code, but when that code change needs a database schema change, very often this very slick, efficient pipeline process will stall while a real live human DBA goes away and does something relatively manual to drive a DB2 change tool before the whole process can then fire up again to complete the rest of the automation. So very often the objective here in getting involved in this is to take the DB2 schema change process, integrate that into the wider DevOps processes that are being used inside an organization in order to get all the same benefits for that as you get from the wider code deployment. So reducing cycle time, reducing the scope for human error, reducing the amount of manual time and effort so that you can free up that valuable DBA who's got a lot of years of experience to go away and do more valuable things such as performance tuning or problem analysis or whatever else that the organization wants that DBA to get involved with. And we need to do all that without increasing the risk associated with application change. So one of the huge benefits of DB2 and mainframes in general is it's seen as a very robust environment. We've got some very good processes that have sometimes built up over many decades to ensure that we can deliver change into production in a very controlled way to make sure that we maintain application availability. And the last thing we want to do by increasing these cycle times and making the organization a bit more agile is to increase additional risk and increase additional application instability by doing that. So we need to keep those checks and balances in place to make sure that although we are automating a lot of this and we're increasing the cycle times and making sure that we can deliver these changes more efficiently, we're not doing that at the cost of lots of poor schema change going into production and making our applications perform poorly or unstable. So there's two fundamental ways of delivering schema change. And again, this is nothing to do with DevOps. This has always been the case, but it does have a relevance in terms of how you actually automate this stuff. The way in which most mainframe DB2 sites do it, and the way in which I personally believe is involves the least compromise, is the compare approach. That's what most of the tools vendors up in the DB2 mainframe space use as their standard approach. You'll have some form of master or main DDL that will be your input. That's your kind of reference schema that says how you want a particular environment to look. You'll then go through a compare process where you will get the master DDL compared against the target DB2 schema that you are looking to implement. The compare process will figure out the changes, the differences between your schema and the target schema. It will generate an implementation script that is specific to that environment, and it's going to go away and make all of the changes necessary to make your target schema look like that main DDL. And at some point, you will take that implementation script and you'll actually execute it against that target schema in order to implement the change. And there are all sorts of advantages to doing it this way, which I'll cover in a bit more detail on the next slide. The alternative is known by various names. I refer to it as the Delta approach. That basically involves specific upgrade scripts that will take your schema from one version to the next. So you might have a script which incidentally may have been originally generated via a compare in exactly the same way, but once you've generated that script, it kind of becomes set in stone. That's your script to upgrade your database from version 1 to version 2. You may have another script then to update it from version 2 to version 3, and so on. And once you have these scripts, you simply run these scripts against each target schema in succession as you move on your route to live. They never change, and you run essentially the same scripts in all environments on your route to live. And that has some advantages in terms of consistency and knowing exactly what you're going to be doing. It has some disadvantages in terms of kind of relying on your schemas all being in a consistent state to start with. So I very much advocate the compare approach when it comes to automating schema change. There are certainly reasons why you may want to consider Delta. I'm not for the moment suggesting it's a slam dunk here in terms of compare always being best, but I believe that compare gives the best general balance in terms of the most robust way of automating this schema change. So on this next slide, I've just summarized some of the major advantages of each. Probably the top two are probably the most important ones for me. It's very robust. You can take any given environment from any version to any version with a single operation. So if we go back here and just look, if I had a particular schema here, an environment which had been left for a while and was still at version 1, and I needed to get that to version 4, using the Delta approach, I'd have to individually run each one of these scripts to get it to version 2, then to version 3, then to version 4. With the compare approach, I can take my version 4 schema, compare it directly to my version 1 target, and it will come up with an implementation script that's going to do all of the changes in one script to be able to go and do that. And if you've got several intermediate changes here where you perhaps changed a column from varchar 20 to 40 here and 40 to 60 here and 60 back to 30 here, rather than implementing each of those changes one at a time with maybe multiple unloads and reloads, here you can go away and implement just the single change to take you directly to whatever target you want to get to. We're also guaranteeing consistency because we're always comparing our target to a single version of the truth with our main DDL. It means that we're guaranteed at the end of it to have a schema which is consistent with our reference, our target DDL. And that means that any inconsistencies that may have built up in our schemas over the years, especially in test environments, will all get ironed out as we move through the route to live. We can have a very high degree of confidence that by the time we've moved all the way through the route to live, that our schemas are in lockstep, We're going to get consistent testing results through as we run our automated tests on the various environments, because we can be very confident that all of those schemas are consistent with one another. If we just run upgrade scripts, any inconsistencies that may have been lurking inside that schema may not ever get realized. So unless we're directly addressing those inconsistencies by making changes inside the scripts, it could be that some columns that are defined nullable rather than not null, or additional columns or other changes in the way the schema is defined may not actually be apparent as part of the upgrade, but may impact our testing results and may give us some issues in terms of the consistency of those testing results as we move through to live. Other advantages here, so it's easy to create new environments using the compare approach. You simply point the process at a blank environment, at a schema that doesn't exist, and the compare process essentially generates a complete DDL deck for all of the objects inside that environment, and allows you to very rapidly define complete new test environments. Very minimal inputs. We just basically need to give it the name of the target DDL that we want to use, and the name of our target environment, and the process then goes away and does the rest. We've got very easy rollback. It's just as easy for us to go away, and if this is at version 6, our target schema, and we want to take it back to version 5, we simply point the version 5 DDL at our target, and the compare and implementation script will then essentially regress our target environment back to the version 5 schema that we had. So it's bi-directional by design, whereas the Delta is inherently directional in terms of the upgrade scripts. If I wanted to get a version 2 to version 1 script, I'm going to have to go away and specifically create that script and add it to my script repository. Of course, there are some advantages on Delta. I mean, there is some open source tooling available to go do this. Typically, this kind of compare and execute process will be wrapped up in vendor tooling. So the likes of IBM and BMC and Broadcom all supply these things, but they are paid licensed products. There is open source capability for tools such as Liquibase that allow you to go away and use this Delta approach. So there's some advantages there if you happen to be one of the very small minority of DB2 sites that don't have a vendor solution. Probably closer to existing deployment processes, so it may be that this is easier to implement as alongside your application processes. You can use the same script in all environments, which means that it's a bit more predictable in knowing exactly what's going to be inside that script. But of course, the elapsed time for running that script may vary massively. If I'm unloading and reloading a test table that's got a few hundred rows, that's going to be a very different proposition to potentially unloading and reloading a table in production, which may have thousands or millions of rows and may have a fairly significant service impact to go and implement that schema change. So although you know that the process is fairly consistent, the impact of that process may vary wildly still from environment to environment. Like many other aspects of DevOps, I think it's fair to say there's probably nothing new under the sun. So the whole prospect of automating schema change, and again, I've used the compare approach here in this example. It's been possible to do this for many, many years. So IBM, BMC, Broadcom, CA, Platinum way back in the day, have all provided tooling for many decades now around DB2 for ZOS to go away and allow you to go away and do this compare, generate an execution script and go away and run that. So that's been available for many years. All you need to do in order to do DevOps and to automate this is really to have a way of orchestrating the steps in that deployment process. And of course, although there are now new sexy tools such as Urban Code and Jenkins to go away and do this orchestration, there's always been ways of doing that without those sexy tools on the mainframe. So you could use a job scheduler, you can use Rex, you can use ISPF, skeletons and panels. There's always been ways of going away and doing this orchestration. And what I suggest when I work with customers on this is we very much keep the traditional change management tools. There's a huge amount of intellectual capital that's gone into those tools over the years. So if you're a BMC site or an IBM site or a Broadcom site, your DBAs, your processors will have built up a lot of knowledge and trust in those tools over the years you know how they work, you know what they do, you know you can trust them to go away and reliably deliver that change. So why would you want to go away and rip that out when you want to go away and fully automate this? So the approach is typically to keep those traditional tools and then use a more modern orchestration tool to go away and invoke those tools and allow those schema changes to run alongside the code deployments in a way which is a natural fit to the new kind of DevOps ways of working. So that's pretty much what we do with this stuff. We use the tried and tested tools behind the scenes to do the heavy lifting for the schema change, to know which plans need to be and packages need to be rebound as a result of dropping and recreating tables, to know how to go away and put away all of the grants and indexes and views and dependent objects if a drop and recreate has to be done, do all that kind of heavy lifting that a schema change product does, but to wrap that around some modern orchestration tooling such as IBM Urban Code or Jenkins or whatever orchestration tool you're using, and allow that then to be part of a wider DevOps implementation. So this is a typical kind of workflow. Again, many other tooling options are available. So please don't look at this as being a definitive way that you have to do it. There are many, many tooling changes here. But the way in which we've done this with several customers now, we have our DDL stored in an SCM such as Git. Git is one of those which, although it's one of many SCMs, it tends to be a de facto standard in terms of SCMs that many DevOps engineers are very comfortable using. It can deal with DDL in exactly the same way as it can any other type of code. You need some way of allowing developers to view and edit the DDL, the schema that's inside Git. We've been through several iterations here, so you can use tools such as IBM Data Studio. There are products out there such as Irwin, which allow you to visually go away and store schemas and database designs and then spit out the DDL at the end. What we're increasingly seeing people getting interested in is using text editors such as Visual Studio Code. There's a developer extension, a DB2 developer extension available for that, which understands DB2 syntax, gives you some nice abilities around that, which have a big overlap in terms of IBM Data Studio, but it gives syntax highlighting and things like that. So it's very easy for an engineer or a DBA to use Visual Studio Code to view and to edit the DDL that sits inside Git. We've got all of the power of the versioning and branching and merging that Git gives us, which I'll talk about a bit more in a few slides' time. But by editing that code, we can have some automation in place here that as soon as that set of changes is committed and pushed to the Git repo, we can then trigger a process. In this particular example, we're doing some static analysis of the DDL that allows us to go away and do a QA check in effect to make sure that the updates adhere to site standards and guidelines. And I'll talk more about that in a moment. And then the process will basically pick up that DDL and it will deploy all of the various bits of DDL that have changed, all of the dependent objects into something we call a DDL package, and it will push that out to all of the back-end deployment environments. So if you have 3 or 4 physical LPARs or sysplexes on your route to live, it can take that DDL, push it out to all of the target platforms. If you're doing virtual mainframes, IBM ZDTs, to go away and have virtual mainframe environments, maybe as a unit test, it can also deploy that DDL package out to those things as well. And all of that happens automatically as a result of the engineer or DBA editing something in Visual Studio Code, using the inbuilt Git extension for Visual Studio Code to go away and check in and push that change into the DDL repo. And then we can use the automation that's built into Git and use a bit of Jenkins and Urban Code automation to do the SonarQube analysis and to push that package out. So that's obviously done once for each set of changes. You can tag that change with a particular change ID, and then that change is ready for deployment to your backend DB2 environments. So that's really where this second process to actually deploy comes to. In this particular example, I'm using BMC Change Manager as a means of deploying that change. it could just as easily be the equivalent tooling that comes from it from any other vendor. And then we go through the standard compare process that we talked about earlier on, where you're taking the DDL package, which is, as I said, it's a superset of all of the various bits of DDL that may have changed in this particular set of changes. We're going to compare that to our target schema in the various environments on our route to live. We're going to generate an execution script. We're probably going to pause and wait for a DBA to approve that deployment before then going away and executing that particular change. Okay, so I'm just going to pause very briefly there. That was all by way of kind of background. I want to spend the next 20-25 minutes talking about some of the real world challenges and solutions that come about when you try to do this stuff. But before I move on, does anybody have any questions about anything that I've said so far? Please either just raise your hand or pop a message in chat if you do. Okay, so in terms of real world challenges, I've come up with 8 different areas here. It's not to say that these are the only 8 challenges that we've had. There's been many, but I've tried to pick out the major ones, which I think have been real learning points in terms of the journey we've taken on this, but also I think that are going to be quite widely applicable to anyone that's going to go down the process of actually automating this stuff. So the first one is versioning. I think it's something that's kind of fundamental if you're going to be using something like Git to store your DDL. And if you're going to be using multiple versions to input into the compare process, you need a robust way to be able to version that DDL and to be able to refer to specific versions to go away and put into the compare process. So as I said on the slide here, DevOps normally goes hand in hand with agile methodologies. They've all kind of got a similar ethos in terms of reducing cycle times, improving the time to market, speeding up the delivery of change in a reliable and robust fashion. And typically that will mean that you're going to have multiple sprints, multiple feature teams that are developing concurrently. And if those multiple feature teams are going to be changing code which has schema implications, that means you may well have multiple versions of your DDL schema, which are all kind of being developed concurrently. And you need some way of being able to manage that. So in the same way as you might use things like branch and merge capability in Git or whatever SCM you're using for your code, so that you can have multiple versions of code which are being developed concurrently, you can do exactly the same thing with the DDL if you're storing that DDL inside something like Git. So most SCMs, and again, I'm going to carry on using Git here because it's by far and away the most popular kind of DevOps SCM to use. But most source control systems have the same kind of concepts as the Git has in terms of being able to branch the DDL or the code that you're using, have concurrent development of that, and at some point merge those changes back into your main line to be able to have a new baseline for that code. So the way in which we do this, Git and again other SCMs allow specific commits, specific sets of changes to be tagged with an identifier of your choice. And once you've done that tagging, we can use that to denote a specific version of the DDL and schema. So the way in which we use this, we use these tags to specify an RFC ID, a particular ID to tag a set of changes to the DB2 schema, essentially a version ID for that particular schema. You can use tags, you can also use commit messages for this. And if you're relying on that, for example, we use it a lot as an element of a lot of dataset names for things like the DDL package we deliver onto the mainframe. If you're going to use it as part of a dataset name, you obviously need to make sure it's not greater than 8 characters. It starts with an alphabetic character, and it essentially fits ZOS dataset naming standards. So you can use things like Git policies to make sure that at the time a developer or a DBA tags a particular Git commit, that it adheres to these standards. And in fact, it'll refuse to allow the developer or the engineer to commit and push those changes if that doesn't actually adhere to those standards. So that obviously means it's a lot easier to make sure you can rely on the fact that this tag is going to be valid later on. So this is the kind of thing that you tend to see a lot when it comes to talk about branch and merge. So we've got our main production DDL, our current production DDL here. At a previous commit, I've called this main A. At some point, you may set up a feature team, called it feature one here, which is going to branch this. It's going to go away based upon that main, but it's going to start making some changes. So each of these blue dots here are commit points. So it's going to make a change here, which we called feature 1A, another change called feature 1B. At some point when that gets implemented in production, we can merge that set of changes back in. That becomes our new baseline in production. At the same time, concurrently, we may have another feature team which has taken its own copy of the DDL. It's making its own changes, its own commits. We can then, at some point when that hits production, merge that back into our main DDL branch as well. And this kind of processing is using the built-in capabilities of the SCM directly. So there's nothing DB2 specific here. This is just another bunch of code as far as Git or the SCM is concerned. But at the time you merge those changes back in, it does have the capability to detect if there are any potential conflicts. So the way in which we tend to chunk this up is usually to have chunks of DDL at the table space level. So we'll have all of the dependent objects for that table space, all of the tables, all of the indexes, the views, the triggers that depend upon that particular table will all be in a single DDL object. And we'll then look at that as a single discrete blob for management inside the SCM. If we happen to have a situation where feature one had gone away and changed a particular table space or dependent object, and feature two had changed that same table space, so we had a potential conflict, Git or whatever SCM we're using would detect the fact that there had been two changes to the same member, the same chunk of DDL, if you like. As long as they don't directly conflict, it can just go away and do the merge directly. If they did directly conflict, we'd still have to have some manual intervention here in order to reconcile those changes and make sure that we could actually come up with a single consistent set. So there's no magic here. It still requires some manual intervention sometimes if you happen to hit exactly the same object. But most of the time, even with concurrent feature teams, you tend to be hitting slightly different objects. And most of the time, you'll find that unless you've got an exceptionally active set of developments, the merge process can be pretty much done without a significant amount of human level intervention. Okay, so that's DDL versioning. With that versioning in mind then, the first challenge you'll find often when it comes to going away and implementing automation is to get our base level of DTL, our baseline, our production, our current production DDL extracted and put into Git or whatever SCM you're using in order to allow you to start using the automation. So there'll typically be, unless you happen to be an organization that has traditionally held the DDL and versioned it and kept it rigorously updated, and I don't see many of those, most of the time it's going to involve you going to your production environment, extracting the DDL from your production structures, and typically that will be done at the database level, and then splitting the DDL into tablespace level files, so individual tablespace level files. So typically we'll use some recs which we produced to go away and take a single database level DDL file and split it into multiple tablespace level files. You'll then take those individual files and import them into your SCM. Typically that will be in a nice structure so that you'll have a directory for the database and then a subdirectory in there for each of the tablespace files that you want to go away and push in. And that will form your main branch. So going back to this diagram, that may be your starting position here in your main branch. But typically, when you do this, there may be some in-flight changes. So although you've captured your production definition, you may want to, you may have some in-flight changes that are earlier in the route to live that are being developed. So you're then going to have to go away and layer on top of that, create a branch for any in-flight features that you may have, and go away and update that baseline production DDL with any in-flight changes that may be being developed by feature teams or sprints which are actually active. So you may have to go through this a few times in order to get an accurate representation of any in-flight changes, and then finally look to go away and do some clean compares to make sure that any particular moment in time, you can compare one of these sets of DDL with the target environment that that DDL is supposed to represent, and make sure you get a good clean compare and you're not seeing any changes in between those. So this can be a bit of an iterative process sometimes, and depending on how active you are in terms of your development, it can be quite painful sometimes to be able to get from a situation where you're not managing any of your DDL to a situation where you've captured your production DDL and you've got all of your in-flight changes captured and ready to go. But once it's done, and you can then operate on a kind of an ongoing basis from there. So I mentioned earlier on quality assurance inside the process. So it's all very well and good to allow engineers and DBAs to go away and make changes to DDL and to give them things like Visual Studio Code to be able to very quickly and effectively view the DDL that you're storing inside your SCM, make some changes and have this wonderful automation as soon as they've made the change, go away and push that change up to the mainframe. But if we're empowering engineers, developers to go away and make these changes, we need some way to make sure that we're keeping the quality levels up and we're not breaking naming standards, or we're not creating some issues in terms of poor schema changes being pushed through to the mainframe and potentially deployed to our environments. So ideally what we want is some way of being able to check the quality of these changes and to do it early enough in the process that we're not leaving ourselves open to those changes being deployed to one or more environments and then having to be unpicked because a DBA gets a chance to look at it and says, you know, you're breaking all of our standards here, or you've gone away and broken our performance guidelines or other guidelines in terms of availability that we put in place in order to protect our service. So we need some way of being able to do this. So one way you can do that is to go away and use an industry standard tool such as SonarQube. So SonarQube is a static analysis tool. It's very often used in DevOps tool chains to assess the quality of a code change that's been made by a developer or an engineer. So by default, it tends to be focused very much on application code. So you'll see SonarQube being used very extensively for checking the quality of code after a developer goes away and makes a change to code. But it's got an extensible architecture, which means that you can very quickly and easily extend it to go away and do checking against things like DB2, DDL, and DML as well. So if you go in and do that extending, create a plugin so that it can understand the syntax and structure of DB2, DDL, you can then start writing a set of rules inside that engine to go away and do things like enforce basic naming standards, enforce guidelines to make sure that your basic site standards are being checked. And if they're being broken, that DDL never gets anywhere near the mainframe or a deployment environment. You essentially break the build early enough in the process so that you can ensure that you've got at least got a basic level of quality that's coming through to anything that's deployed over to the mainframe. So I've kind of summarized here over on the right, the same process that we looked at earlier on. We've got the DBA or the engineer making changes to the DDL. As soon as they commit and push those changes to Git, our Git webhook fires, invokes our Jenkins build. That does all of the packaging of all of the DDL that's just been changed, and invokes, in our case, an urban code deploy process. That urban code deploy process then goes away and invokes SonarQube, and it takes the DDL that's been packaged, all of the DDL that's just been changed, and it will throw that at SonarQube, we'll assess the quality of that DDL by running it through the rules engine. SonarCube's got this fantastic terminology here, and it looks for code smells. And a smell is something that, if you get a bad smell, it's basically something which is potentially unsavory inside that code. That could be an index that's been created with the wrong naming standard. It could be a table space that's been created with close yes rather than close no. It could be a multi-table table space. You know, it could be anything that you have encoded inside your standards and guidelines for your organization. And as long as you can specify that in the form of a rule, then we can put that rule inside SonarCube, and we can essentially get this process to break at this stage here if one or more of those rules isn't adhered to. And if it does break, then you never execute this last stage, which is to deploy that DDL package to your back-end processors to allow you to go away and deploy that against schema environments. So the DBAs can be sure that before the DDL gets anywhere near the mainframe, it at least adheres to a basic set of quality standards. It doesn't mean that it's definitely going to be okay, and I'm not advocating this as a replacement to have a real experienced human DBA review that. So one thing that we don't talk about over here is, as part of this last stage, the DBA actually gets an email to inform him or her that a new version of the code has been successfully deployed up to the mainframe. So it's passed the UCD checks. So you know that basic things like naming standards and basic standards and guidelines will have been enforced, but the DBA still gets a notification to allow him or her to go away and take a look at that new version to make sure that there's no other potential issues inside there. But they can do so in the knowledge that at least the basic level of quality assurance has been done. Okay, that brings me nicely onto the next level. So although you've got those basic checks in place there, when you actually come to deploy this, we still want to include an experienced human being inside this to provide a final level of approval. So even though we've got the updated DDL deployed to our back end and it's been through SonarCube checking, hopefully by the time it gets to the higher environments before you go into production, it's been through a number of lower level environments and all of the automated testing has been done. We still want to make sure there's a human being in here to allow us to have a final check before we actually go away and implement these schema changes. So it's critical that you build in some kind of manual approval step into this automation. Automation is great, takes away the donkey work, it reduces the amount of human error, all of those great things, but we still need that human being, that experienced DBA, going in there and just giving it a quick once over before we actually allow the automation to go away and implement those schema changes. So although the static analysis can eliminate most of the basic issues, we still want that final sense check. So we do that by putting a manual step into the UCD process, and we do that after it's generated the execution script, but before it executes that execution script. And that allows us then to send the DBA an automated email that includes some attachments. Those attachments are typically include the execution JCL, it's about to go away and be executed, includes the execution script, the work list that actually contains all of the steps that are going to be run in order to implement that change. And without going anywhere near the mainframe, the DBA can see a change has been requested, can see what's about to run, and then can click on an approval link to say yes or no, I'm happy for that to be implemented, or no, I can see a potential issue here. There's something inside that change script that doesn't look right, and either pause and go talk to the engineer that requested it to figure out more, or just reject the change outright, in which case, obviously, there's a chance then to go away and review and correct the process. We have got to the stage now where that approval step can be bypassed in lower level. So if you want to support rapid prototyping, if the target is, say, a virtual ZD&T environment, you can bypass that approval step and allow engineers to very rapidly prototype changes and then maybe introduce that approval step in higher level environments. Not much to say here in terms of deployment logging, other than it's a good idea. The fact that you've got this process means that you can create tables that look a bit like this at the bottom here, where as part of the deployment process, when that deployment process is successful, you can then start to maintain a log of those deployments. You can see who requested the deployment, what objects were actually involved in terms of the objects that were changed, what target environment you were going to, and the RFC or the change numbers associated with that. That gives you a really valuable audit trail so that you know in great detail exactly which level a given environment is at. So you can very easily use this information to produce environment reports. And anyone that's been involved in environment management, you know that's a fantastic thing to be able to know what particular level a particular environment is at. But you can also use it to drive production copyback processing, which is what I really want to spend the last few minutes here talking about before I throw this open for questions. So the automation I've talked about allows you to implement change on the route to live, so you can go through your development, test environments into production. It's quite common to have multiple parallel environments on the route to live, and maybe only use one route through there as you get to production. So a common requirement in many of these parallel environments is then to take that new level of the schema change that you've just implemented in production and make sure you're copying that back to the previous levels in your route to live to make sure those are at least at the production level for testing. So the fact that we're now automating the deployment to production, the fact that we're now logging what all of those other environments are at, means that we can also automate that production copyback processing as well. So we can now put a trigger on our production implementation, and we can use that trigger to go away, look at all of the earlier environments and upgrade those at least to the level of our production environment as well. And I've got a nice diagram here that kind of illustrates that in action. So you can see we've got a few concurrent environments going on here. So our dev level, we've got dev 1, dev 2, dev 3. We've got some system integration testing, again, concurrent 1, 2, 3 levels here. We've got a couple of user acceptance testing, and we've got our production. Obviously, a simplified version of this just for the purposes of illustration here. And in green here, you can see we've got these environments at version 6 of our schema. Our production and a few of these other environments are at version 5. And over in dev 3 here, we've got a new level or environment here, version 7, that's just being implemented and being tested. So version 6 is what we've currently pushed through to SIT1 and UAT. We've got our previous environments here still sitting at version 5 and production at version 5. When we use our automation now to go away and deploy version 6 over to production, we can do that using our automated deployment. As part of doing that, we can now have a trigger that says if we're actually deploying to production, go away and use copyback processing to go away and review what our other environments are. And if they are a lower level than version 6, bring them up to at least production environment. So the very process of going away and successfully deploying to production will then kick off processes that will take these environments that were previously at a lower version of production and upgrade those to a minimum to version 6 as well. Note that dev 3, which was already at a higher level than these, won't be touched. That will stay there at the higher level because you don't want to regress that change. These were all back level and can be upgraded. This was already at a higher level. And because we know what all of the levels are, because we have all of that information inside that logging table, we're able to make intelligent decisions in terms of how we go away and proactively go away and upgrade these environments. Okay, so very quickly, it is possible to drive all of this via a Jenkins pipeline as well. So typically, you'd want to do this in your development environments. If you, as in our previous environment here, if you have multiple environments, rather than going away and deploying separately to each environment, I can have a Jenkins script that will go away and implement all of my SIT environments to the same level. I've operated in some environments where some applications have tens or even in some cases hundreds of development environments, and a single Jenkins script can go away and trigger multiple deployments. And that means that you take a lot of a lot of donkey work out of here just by passing a simple change ID to the Jenkins script. You can get one process to go away and deploy to multiple environments. And the final thing I want to talk to you about here is really the ultimate that we've taken this to in terms of ease of deployment for actually requesting these changes. So many of you will be familiar with Jira. Jira is a issue tracking tool which is commonly used in many DevOps environments to track issues and changes. And it's quite common to see Jira being used for DDL changes as well, where you may have swim lanes like I've got down in the bottom right here, where you've essentially got swim lanes that reflect your route to live. So in this particular case, we've got changes that are in design, in CIT, in SIT, NFT, production, and each individual ticket here represents a particular DDL change, a particular set of changes you're making to your schema. And traditionally, as you pushed a set of changes into a given set of environments, you would drag the ticket around in the swim lanes or update the status in order to track which set of changes have been moved to a particular environment. So what we realized is that this was actually an opportunity not just to retrospectively track these changes, but actually to trigger the changes by actually changing the status of these Jira tickets. So what we did was to deploy some automation here, which is driven by that Jira status change. So when a developer or an engineer picks up one of these DDL tickets and drags it into a new swim lane, we use a Jira webhook here to go away, invoke a Jenkins process. Jenkins process grabs the payload from that Jira webhook to figure out what's changed, grabs the contents of that DDL ticket to figure out exactly which bits of DDL are actually implemented. And we then use that information to format a call to Urban Code to go away and initiate the deployment to those environments. So we're no longer having the tail wagging the dog and updating Jira once a deployment has been done. We're triggering the deployment as a result of changing the status in Jira. And simply picking up a ticket and dragging it to a new swim lane here is enough to go away and trigger the upgrade of the environments inside that particular level on the route to live. And then the final step here is for us to use a plugin for Urban Code to physically go away and update that Jira ticket to record the fact that we have successfully deployed those changes to that particular environment. If there are any issues in the process, and I'm not trying to make out that this is always completely seamless. Of course, there are always situations where you may encounter space problems or whatever that may cause a deployment to fail. Again, a critical error message is written across to that Jira ticket, which highlights to the engineer who requested the deployment that there's been some issue, so that they or the DBA can go away and follow up to figure out what that might have been the problem. But this is an incredibly powerful thing now, where you can actually drive this schema change from a very intuitive graphical process here and potentially go away and upgrade tens or hundreds of environments as easily as dragging a Jira ticket from one swim lane to the next. Okay, I think I've talked about the majority of the benefits of this. We're using existing trusted DB2 specific tooling to do all of that heavy lifting for the schema change deployment. But we're integrating that into the new DevOps tooling, which means that you can integrate schema change alongside code change. I could essentially press one button inside my orchestration tool and have that process kick off a code deployment and a DB2 schema change deployment as part of the same change, and tightly integrate those two. So if there's a problem in one, we roll back the change in both. And that obviously gives us a lot of power in terms of deploying these changes. We're using familiar DevOps tools. All of us here are probably long in the tooth enough to be very familiar with ISPF and green screen. Newer generations of developers and engineers are less comfortable in that environment, and being able to go away and use things like Visual Studio Code, Jenkins, Urban Code to go away and request and deploy these things is much more comfortable for many people than logging onto a TSO session and doing the same thing. We've seen and continue to see a big reduction in the time and effort required because we're doing a lot of automation of the donkey work required to go and implement this. that frees up valuable time for engineers and DBAs to go away and do things which are much better suited to their skills, rather than mindlessly going away and rerunning deployment scripts in 20 or 30 or 100 different environments time after time. And of course, with that, automation becomes a significant reduction in the potential for human error. Of course, the fact that we've got a single version of the truth with the DDL, and you're comparing that single version of the truth with multiple environments, you vastly decrease the scope for inconsistencies. Every single time that I've gone to a new application team or a new client and done the compare process, the DBAs have been relatively confident that their environments are all in lockstep. And every single time we've found unexpected changes that have been there for all sorts of historical reasons inside these environments. And we iron out all of those historical inconsistencies by using this rigorous compare process. As I said earlier on, we can very quickly jump forwards and backwards, multiple versions, and take any target environment to any DDL level very quickly and easily. That copy back processing means that we are ensuring that at the bare minimum, all of our test environments are at production level, which means that we are increasing the quality of our testing, and we're not doing testing on back level versions of the schema, which can cause issues later on in the deployment processes. We've got inbuilt back out capabilities here, and it means that because we've got a single standardized process, we can very easily put things like those DDL quality checks in. So I've run a bit longer here than I intended to run, but we still do have a few minutes here. If anybody has any questions, then please do ask now, and I will do my best to answer them. And thank you, Paul, for your kind words.
Yep, anybody's got a question, please put up the hand. I can unmute you or stick it in chat, and you can ask. While we're waiting for those questions to pop in, thanks very much, Julian. That's a great session. Just a quick look forward. We've got 30-minute break for coffee. Then we've got some session for DB2 on ZOSMF REST APIs, which looks excellent. Just about lunchtime, we've got another session, which is about fantastic online nightmares, where to find them. I've seen a few this week, so I could add to that. And then we finish off the day, a couple of sessions this afternoon, one at 2 around DevOps versus DBAs, and finish off with Chris Crone on continuous delivery. So have we got any questions? Gosh, it's a quiet, it's a 9 o'clock session, isn't it? Everybody's just still waking up a bit.
Absolutely.
I'm sure if they've got any questions, they can ping you an email or something, Jules, after the after today. So
okay, so we haven't had one just pop in on the chat. Oh. So the question is, when does the compare process happen, during the deployment or DDL packaging? So I talked about back at the beginning of the presentation, I talked about two separate, oh, I've lost it. I talked about two separate stages to the deployment. I talked about the deployment of the change of the DDL. So that's when the DDL patching happens. You change the DDL and it gets put to the back-end environment. And then the second process is actually deploying to a particular environment, and the compare happens as part of that second process. So each time you deploy to a specific environment, you compare the DDL to your target environment. It generates the changes, generates an execution script that is specific to that target environment. So hopefully that that answers the question, Manoj. Any other questions before we wrap up? Okay, so thank you everyone for your attention, and hopefully you'll enjoy the rest of the day.
Thanks so much, Julian. Really good session. Just a final reminder that you do get the recorded sessions available in a couple of weeks. So if anybody wants to see it again, or if somebody else has missed it, you can pass on the news that they can get them as a recorded session later on. Thanks so much, everyone. Grab a coffee. We'll be back at 10:30. Thank you.
Bye.